Okay, just a quick word or two about probability and determining being able to determine probability. Lots of different examples of doing probability and stats are a huge kind of thing, and probability is part of that, I guess. A huge in any kind of field, whether you're in business or sports or whatever it is, there's always going to be some kind of statistics or probability that something will happen. And so just we'll give you just a basic understanding of what probability is. One tool I quite like, and it's quite interesting, if you go to Wolfram Alpha, you don't need the Pro version, but if you go to Wolfram Alpha, there's a little box and you can type stuff out. And if you type out poker royal flush, you can, in there, it shows you what's the probability of getting a royal flush from a hand of 52 cards. Interesting, but you can type quite a bit of things in that Wolfram Alpha search box to find things. This is sort of more of a statistical standard curve plot, but in there you can talk about the statistics of any kind of population or anything that follows a standard curve. And when you look at the area under the curve, this part here is you're looking at the probability of something falling in that area, or the probability of something falling in that area. So maybe should define a couple of things or different types of probability. The two just basic ones we're going to look at is something called an experimental probability and a theoretical probability. Experimental probability is when you get stats, numbers, and you actually count them up and see what the probability is. So why don't I've got a little dice here, a die, and let's see what the probability of rolling I don't know, a 3. So I want to know the probability, and maybe I'll write it in the right way. So the probability of getting a 3. And what I'm looking for is an experimental probability. So I'm not just looking at it theoretically, I'm looking at it experimentally. So here's a die, let's try it. So here I roll it once. That's a 6, no. So a 6, maybe I'll roll it 10 times. Roll it again, I get a 5. Okay, roll it again. I get a 1. Oh, I need to get a 3. A 1, another 1. Oh, this is awkward. I have to use different tools every time. Roll it, I get a 2. Ooh, closer. 2, so how many is that? 1, 2, 3, 4, 5 done. Okay, I gotta go 5 more. Another 1. Okay, another one. A 2. Okay, another one. A 6. So how many is that? 1, 2, 3, 4, 5, 6, 7, 8. 2 more. A 4. And a 6. Perfect. Okay, so there I rolled this die here 10 times. And so the probability of getting a 3, in looking at that, when I look at it, in order to determine probability, you always figure out a fraction. And the top number is going to be favorable things, so things that you wanted to have happen. And on the bottom of the fraction is the total number of things that did happen. So in this case, experimentally, the probability of rolling a 3, I didn't get any 3s, and so that would be 0 out of I rolled it 10 times. So experimentally, the probability of getting a 3 with this particular die was 0 out of 10. Now, if I look at it theoretically, there again I'm looking at maybe not, I guess, favorable or things that you want to have happen, or maybe I'll write possible things on top over the total things on the bottom. Whereas experimental, this wasn't possible things, this was actually how many did happen. How many 3s did I get? I didn't get any 3s. Theoretically, though, if I look at a die, there's 6 sides, there's one of them that's a 3. So the probability of rolling a 3 theoretically, well, there's 1 3 and there's 6 sides altogether. So theoretically, the probability of getting a 3 is 1 over 6. Interesting that I didn't get a 3 up here, but notice that the probability of rolling, say, a 1, 1, 2, 3, probability of rolling a 1 was 3/10. Whoops. 3/10, which is quite high. That's like 30%. That's significantly higher than this one, which is about, I think, 16 or 17%. Now, if you were to experimentally roll this die instead of 10 times, maybe 1,000 times, maybe 1,000,000,000 times, you'd find that your experimental probability and your theoretical probability would start to get closer and closer. Okay, so probability that an event cannot occur would be 0. Probability that it's certain to occur would be 1. So anytime you're looking at the probability of any event happening, the number that you get is always between 0 and 1. Up here, or back here, when I said 30%, that is a percentage. I probably should have written it as 0.30. Same thing down here is 0.17. So this number here is the probability of getting a 1 from that set of 10 that I had. This is the probability, theoretically, of getting a 3 when you roll that die. Okay, you're getting the idea then? Experimental is actual things that happen. Theoretical are ones that possibly could happen. Here's some examples. We talked about that. Here's an example. So we surveyed 200 people. What were you doing February 23rd, 2014? What were you watching on TV? I guess these people weren't watching sleeping on TV, but maybe what were they doing on that particular day? 160 were watching the gold medal game, 15 were watching cartoons, 10 were sleeping, 5 were watching the news. So what's the probability that you're watching the big game? Probability to be favorable things, so 160 out of 200 people. So if you divide that, it comes out to 0.8. And so 0.8 was the probability that you were watching the game. Probabilities you were sleeping, that would be 10 out of 200, or 0.05, I think. Now you can convert these to percentages by multiplying by 100, and so maybe that gives you a better idea of how many people were doing it, but the probabilities are always between 0 and 1. So 0.80, we're watching the game. If you actually look at the stats, that's what they said, that 80% of the people were watching that game. Okay, so we've done experimental. Theoretical then is, like we said, taking possible things that you want to have happen over the total possible things that could happen. So for example, if you're playing cards, here's a deck of 52 cards. If I want to figure out, and I'm going to draw one card from that deck, what the probability of getting a heart was. Okay, well here's the hearts right there. If you count them up, there's 13 of them. So there's 13 favorable things over a total number of 52 cards. You can simplify that fraction, and of course your probability then of getting a heart would be 1/4, or 0.25. What's the probability of getting a black? Well, here's a bunch of blacks, here's another bunch of blacks. So it looks like half the deck is black. So 26 out of 52 are black, or 1/2, or 0.5, or you could say 50%. So you got a 50% chance of getting a black card. Here's some other interesting questions. What's the probability of getting something less than 4? So these guys here are less than 4. Let's count aces high, should we? Yeah, let's count aces high. So 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 out of 52 that are less than 4. That's the probability of getting something less than 4 then. I probably should simplify that. Probably goes in there 2 and that 13 times. Okay, what's the probability of getting a king? Well, there's 1, 2, 3, 4 kings. So it would be 4 out of 52, or 1 out of 13, or 0. Whatever that comes out to. What's the probability of getting a face card? Well, there's 1, 2, 3 times 4, so there's 12 altogether. So 12 out of 52 cards that would be your probability of getting a face car. Again, you could do it experimentally, and experimentally, unless your draws are high, like doing it 1,000 times, you might get a number that's slightly different than that. This would turn out to be divisible by 4. I think it's 3 over 13. So that's a probability of getting a face card. Okay, maybe the last question we can look at is something that combines a couple. What's the probability when you draw 2 cards that one is a king and one is an ace? So there's 2 different things that are happening. You're getting a king and you're getting an ace. Okay, so let's look at the king. How many cards are there? There's 52 cards. And from there, you're choosing, oh, we're doing probability, just a sec. There are 4 kings out of 52 cards altogether, right? And there's 4 aces out of 52 cards. Well, if you've pulled a king already, then there'll only be 51 cards left. So then by the fundamental counting principle, I pull a king, chances are 4 out of 52. If I pull an ace, the probability is 4 out of 51. And then according to the fundamental counting principle, you would multiply those 2 together. So 4 times 4 is 16 over whatever 52 times 51 is. Okay, hopefully that gives you a good introduction to probability. Try some questions from the book. Again, make sure you're looking at the difference between experimental probability, where you have all the stats and you just count things up, versus theoretical, where you have to look at the total possible things that could happen over the total possible favorable things over the total possible things that could happen.